All right. So the next is the public and a private key concept. So before we move in there, these are some of the commands that you can use on VeraCrypt command line, not the GUI interface. If you have installed VeraCrypt console, that's where you can use these commands. -C to create the container, -D to unmount the container. So creation and deletion, you can just relate it that way. From a mounting a container perspective, just write VeraCrypt, what to mount and where to mount. And then -L will list the encrypted containers which are available, which are mounted. Okay. This is again a wizard stuff on a command line. So once you press VeraCrypt-C, type and enter, it'll ask you certain questions and accordingly the flow will happen. Okay. Now, how many of you are aware about public and a private key concept? Oh, so you're clear about it?
We just came through that.
Okay. Okay, so Joel is clear about it, so probably he can clear a lot of our doubts as well. All right, so we have a public key. And we have a private key. Public key is available to all, private key is available to me as an entity. Okay, who is getting the public key published? So I will have my private key. Now, from an encryption perspective, confidentiality, non-repudiation, integrity. These are few concepts that we can use in a public and a private key. Okay, so if I encrypt a data with a public key and I give it to Joel, and Joel has access to my public key, he will be able to decrypt it easily because it's the common key. Public key, he can decrypt. He will use my public key to decrypt. I will use my public key to encrypt. Okay. So which area does it impact? Yeah, in a positive way or a negative way? Negative, because there is no confidentiality. Everybody has that key. Correct. I want to share some data with Joel so that only Joel can read it. But that key is available to all of you. Right? Like a vacant flat key. Right? So in a public private key, what happened? Two keys exist. Both the keys works together. So if I have a private key, I can encrypt my data with the private key and he can decrypt the data with the public key. Okay. Now, if I encrypt the data with my private key and he can decrypt it with the public key, what area does it impact? Non-repudiation. Why? Because he knows it is me who has sent the data. There is still no confidentiality into it. Right? Still no confidentiality because public key is available to you all as well.
The sender is confirmed to be source is guaranteed. So
yeah.
That's with non-repudiation.
Non-repudiation. So because it is encrypted with my private key and you guys are able to decrypt with my public key. So you know key, this is Paras's key only which has been used here. So non-repudiation. That's what happened in a digital signatures. Okay. Now in hashing, what happened? Hashing is a way of checking the integrity. So if I say Reva, I pass it to a hash algorithm and the output comes as, for example, this. If I give you this, you don't know that it translates to Reva because this is a hash which has been generated. Okay. So you don't know what is the real content. And hashing is a one-way process only. You can't reverse it. Okay. Now, from an integrity standpoint, if I tell you that I have sent you a message which contains a text called Reva, can you confirm whether you have received Reva only or race? So what you will do, you will regenerate or you will reprocess Reva, pass it to hash to match if it is same or not. If what hash I have shared and what hash you have computed, if both are equal, same, similar, then you will say, yes, you have sent Reva, I have received Reva.
Every time the same hash will be created.
Every time same hash will be created. Okay. If I include space Reva, a new hash will be generated. Okay. So anytime that I put a message in a same format, same capital lower, everything same, the moment I pass it on, I will get a same hash all the time. Okay.
The hashing mechanism should also be the same.
Yes. So if I'm using MD5, same value, same algorithm, same result. Same value, different algorithm, different result.
But the sender and receiver should know which algorithm they use.
Yes. So, for example, I have this file one, I have this file. Okay, let's remove both the files. Two files I've created, F1 and F2. Same content. Okay. This is the hash of F1. This is the hash of F2. Okay. Now I go to F2. And at the end, I will just put a space. F1, F2.
They have achieved.
They have changed. F1, F2. This is EC4D59. This is C52980. Okay, that's the effect of rice. Right, so hashing provides me a guarantee that the integrity of the content has not changed. Okay, that's the purpose of integrity. Okay, now let's take an example of a digital signature. So what happens in a digital signature is I have a text which I need to digitally sign and send it to somebody, let's say Vasudev or Niranjan. Vasudev or Niranjan? Niranjan. So I have to send it to Niranjan, let's say. Okay. So what I will do is I will first compute a hash of it. I will compute a hash of it. So hashing algorithm can be MD5, some can be SHA-256. So let's say I get some value. Assumingly this is the value. Okay. Now what I will do is I will encrypt this hash. I will encrypt this hash using my private key. And I will get the encrypted hash value here. Some text will come, which is the encrypted hash value. Okay. Now in digital signature, what you are doing, you are trusting the identity of the sender. So what I'll do, I'll send this encrypted hash value plus the clear text to the receiver. Now receiver has to verify my identity. Okay, and he has to verify the integrity as well. That nothing has changed in the entire communication. So this is sender. This is receiver. So on the receiver end, they will get the text. Plus, they will get the encrypted hash value.
That encrypted plus hash will again be encrypted with the public key of the sender.
No, this is a private key with which I have encrypted the hash. So I've got the encrypted hash value. So I will send a text and the encrypted hash value to the receiver. Now what the receiver will do, receiver will use my public key to get to a hash, which is, let's say, the same value. So I have encrypted hash. The receiver will use the encrypted hash, put it through my public key to verify my identity, and will get the hash value. Okay. Now, this text, the receiver or this person who is receiving it will pass it on to a hash and will get another value, which is, let's say, the same. Okay. If these two value matches, if these two value matches, it proves non-repudiation plus integrity. No, digital signatures is nothing about confidentiality.
In a real life, how can we place this level?
So for example, you get a form 16 from your organization, you get that question mark at the bottom of it. So when you click on it, it goes and verifies the identity. The circle comes, takes some 5-10 seconds, and then either a tick or a cross comes. Right? So that's basically, this is what is happening at the back end.
That comes from the other.
Hmm.
Does it happens the signature on an email?
Yes. So wherever you have digital signatures, this is the process. So when you assign a digital signature without confidentiality, so even when you send an email to somebody, you have an option to encrypt that email or digitally sign that email. These two options are available. You can take both or you can take one of it. Right? So once a sender receives an email which is digitally signed, not encrypted, which is like coming from a chairman of the organization, and you have to verify it's a chairman who has sent this email only. You will not encrypt, but you will digitally sign that email. So at the back end, you are trusting the content, whatever is written, plus you are verifying the identity of a chairman as well. Clear? Simple.
So in this scenario, you mentioned that the sender would have to send the text and the encrypted hash to the receiver.
Yes.
So technically speaking, the public key is also of the sender, which he would be having.
Correct.
So in turn, all three should be there at the receiver side, only then he'll be able to.
Otherwise, how would I know? So if I claim that I have sent it, you will use my public key to verify my identity.
Again, you should send me the public key.
Public key is a certificate basically available. So I will not send the public key explicitly, that you will have in your trusted root servers. Clear? Simple? Yeah. Now, when we talk about confidentiality,
Sir, we lost your video. Video.
sorry, you lost
We
the
lost-
video?
Yes, sir.
Wait, Rahul is hacking into the system.
So in digital signature, it's the integrity and the
Non-repudiation.
Because anyone could have used public key to send the same message.
Private key. So for example, if you are sending on my behalf, you will not get that hash. In a reverse process, you will not get that hash.
Because my private key will be different.
Correct.
Now, what I meant to say is, in the previous example, what if the same public key is used on both symmetric keys were used? We would have achieved the
Nothing.
impacted the confidentiality. The same way, the symmetric key if we use even.
Nothing would have been achieved. Not even a non-repudiation. So because it's a common key used by all. So you can use my public key and act on my behalf.
In this example,
I use private key.
but could have as well used public key as well.
No. If I use public key, then nothing is achieved.
See, given a message,
Hmm.
it can be encrypted using private key, decrypted using public key.
So sender, receiver, text. If I encrypted using a public key, I will get an encrypted value. Correct? This is a genuine sender. This is a false sender. He can use a text 1,
Public key.
my public key. So this is my public key. He will use my public key and will get the encrypted text. Correct? How would a receiver know? How can a receiver gauge that who has sent this?
So the question is, given a text can be encrypted using either public or private and decrypt using either public or private. Any combination is possible.
Yes.
So in the just example which you gave, anybody could have used the public key as well.
Correct.
Instead of genuine senders and encrypting using private key, another could have used public key of this sender.
So public key can be opened with a private key can be opened with a public key. So it's like a lock with two keys. So both the keys should go. So there are two holes, there are two punches. So I need to punch both the keys to open the lock. So if I have this key, which is a public key, here it's only a lock, it's only a slot for the private key. I can't put a public key here.
Okay, that won't work.
Okay. Now, coming to the confidentiality. So I have a sender and I have a receiver. Now a sender, because I have to achieve a confidentiality, not the integrity or the non-repudiation, I want to achieve confidentiality, which means the data that I send to Niranjan should be opened by Niranjan only. Okay. So what I will do, I will use receiver's public key. Okay. So I have a text. I will encrypt it with receiver's public key, and I will get the encrypted text. Okay. Who can open this? Who has a private key? Who has a private key? Niraj.
Even though he is having the private key, he will be sharing us only the public.
Public key is available to everybody. So I have a public key of Google. You will have a public key of Microsoft. Everybody has a public key of everyone. It's public. Private key is something that I will have for me. Private key is something that you will have for you. So if I have to send something encrypted text to you, I will use your public key, encrypt it, and then put it in a public. Okay. He doesn't have your private key. He won't be able to open. He won't be able to open.
It's kind of like vice versa. If we encrypt the data with the public key, the receiver should be able to open the private key only.
Yes.
I have a conflict here. So for an example, I have one private key.
You have a private key
You have one public key.
for you.
Okay. For me.
Yes. So you can only encrypt and decrypt with the same public key.
Like a service.
No, tell me.
No, like this.
Ask me, na.
The question for-
Oh, question is changed. All right. So I have this encrypted text. So I will send this encrypted text to the receiver. So receiver will get the encrypted text. Okay. Will put it through the private key and will get the text back.
So we are using the receiver's public key to encrypt, and the receiver side, he is using the own private key to decrypt.
Clear?
So what if the sender is sending some malicious files to the receiver?
Hmm.
And the receiver, he opens it. So that will impact.
So receiver will get the unencrypted malicious binary. So I have put a zipped, let's say I have zipped the malware with, let's say, his public key. I send it to him. He doesn't know what is there in it. So he will use his private key to see the data. So he can decrypt it and he will see a file. Until or unless he clicks on that file and execute, his system is still secure. The moment he clicks onto it, that's where it will get infected. Clear?
So here only confidentiality is.
Here the confidentiality is maintained. Okay, so from a PKI standpoint, it provides you a confidentiality, integrity, and non-repudiation. Okay, what about availability? Why is availability a factor in security?
Because in that CIA triad, if we keep on tuning it, if we move the positioning of our policies towards either confidentiality or integrity, availability becomes a challenge.
No, correct. I'm saying, what is the purpose of availability? Confidentiality is to secure. Integrity is to prove.
When you need something, it is
So basic usage.
Example.
If you try Googling,
like if you need to use a service and you don't have.
Example. This is
like
theory.
Like a DDoS attack. That's also
Yes.
an availability standpoint.
Like a DR.
Yeah.
Like a backup server. like an Active Directory, right? So availability is important, not from an infra standpoint, but from a security services standpoint, right? What if the public key itself is not available to the sender? You won't be able to encrypt it. Right? So from a server's standpoint, services standpoint, availability is also important. But in PKI, the concept of a PKI is around confidentiality, integrity, and non-repudiation. For a banking website, which one do you think is more important, CI or A?
All the
Confidential.
More important. All the three are important.
Confidential.
Any other guess? Okay.
I have to access bank portal. I'm getting using my.
For a bank, not for the customer.
only if it's available.
My services are down. My banking portal is down. What will I do with C&I? My business lost. RBI will penalize me. My shares will go down. My customers won't come to me. I will lose on the transaction fees. So I don't have a business. I'm out of business. What will I do with C&I? Right? It is important. C and I are also very important because they have to sustain that trust. But A is the interface where they interact with the consumer. I have thousands of branches, but all of them are closed. I'm protecting the confidentiality of the data. Right? This is one of the questions asked to me in one of the interviews. Fortunately, I gave the right answer of A. But yeah, that took some time for me as well.
So just to rephrase, the availability is, even if the services of security are not there, still the availability should be there. Is that the purpose?
I'm saying from a business standpoint, think, not from a security standpoint. For a bank, availability is important. Let's say if you take an example of ICICI Bank, you have that grid authentication for a transaction to go through. At the back of a card in ICICI Bank, there is a grid, right? So what if that grid authentication is not available? The two-factor authentication goes for a toss. But still the transactions can happen. Okay? With the transaction password as an alternate mechanism, right? What if in a standard chartered bank where you don't have a grid authentication, the availability of the transaction password itself is down, that module is down, no transaction will happen. Suddenly you will see customers opting out of Standard Chartered and moving to some other bank. So from a business standpoint, availability is important. From a security standpoint, availability of security services are important. Okay, for example, he took an example of a DDoS attack. I am under a DDoS attack. I need a scrubbing center to scrub the data. That is not available. My business will go down. Correct? For example, in a DR situation, my production line is down and my DR is not available, which is a security service. So DR is not available. My systems will go down. Let's say I have a DR okay running, but my antivirus in a DR is not there. I'm exposed. Correct? So availability from a security standpoint, availability of security services are important. From some of the business standpoint, availability takes the precedence. Manufacturing, availability of a assembly line is very important. Oil and gas, availability of the machinery or a refinery is very important. From a IT standpoint, availability of my code repository is very important. From a support standpoint, availability of a voice line is very important. And people, absolutely. That's what we are hiring for. Right? So Availability from a business standpoint is top. Confidentiality and integrity is a second thought. Clear? So being into a security profession, think of a business as well. Because we are a cost to the business. If business doesn't exist, security doesn't have any value. Clear? All right. So that if that concept is clear.
So those two examples, we cover that asymmetry.
Yes.
The digital certificate part did not come into that.
Digital certificate is the first example that we discussed, where we took the hash of the text and then encrypted the hash. We sent the hash to the receiver.
Yeah, so in the second example, it's a public key and a private key.
Hmm.
The first example, it was both of them were asymmetric keys.
There are three examples.
Yeah.
The first was the symmetric, second was the digital certificate.
No, the first one, both private and public, both are key.
That one was symmetric.
In digital signatures, both are used.
Actually, in the we're trying to correlate with that, I think both are trying to correlate.
Okay.
So there, how it is like server is there. When
Okay.
there's a request from the client,
Hmm.
server is going to talk to the central digital certificate authority.
Correct.
And CA is going to send back the
Server.
server.
Certificate.
The certificate will be encrypted with the private key of the server and sent to the requesting client.
Hmm.
And the client will again in turn go and request the central digital
CA.
certificate, CA.
Hmm.
CA is going to respond back with the
Server.
public key of this guy.
Correct.
With that public key, he is going to decrypt it, and then he will see the content of it, which should be matching. I mean, that's what something was like that.
So that's about the trusting identities. Like a digital signature only. It's a digital certificate rather than a digital signature. Correct? So when you go to HTTPS website, what you see is a certificate. That's a certificate which is publicly available for everybody to look at it. Right? How the encryption of a channel happen between a server and a client is what you are saying. That I have to trust the identity of a server. I will go to a CA. I will ask for a server certificate for google.com. This CA will give me a certificate of a google.com. And I will have a certificate issued by google.com. So I will validate whether both the certificates match or not. If both are there, I see I'm browsing www.google.com. On a certificate, it is written www.google.com. Both are equal. Then I have a trust relationship on that particular website. If that trust relationship is established, then I will start to communicate with that website. Otherwise, I will see a cross on the URL. Correct? Clear? Now, from a public and private key perspective, the implementation in Linux, if I have to do, I can use GPG or a GNU PG as a package to do that work for me. Okay. Now, how do I use it? There is a command GPG that I can use on my machine. So when I say GPG and I will say full generate key or generate key, in some systems, it just works as generate key. In some systems, it is a full generate key. So when I use a generate key, it creates a private key for me and saves it under my home directory. Okay, so that's my private key that I am generating. Now, if I similarly, you can generate your private keys as well. Okay, so you can decide on the length, the bit size, algorithm, all that stuff, your name, trust relationship, all that you can, when you say full generate key, it'll ask you for 2 or 3 questions and then it'll generate the key for you. A public and a private key pair, basically it generates. Okay. Now, when my public and private key, or let's say my private key, I believe is compromised, what will I have to do? I have to ignore that or delete that and tell everybody that don't use my public key, I'm compromised. How do I do that? By using a revocation certificate. So when I have generated my public and a private key pair, now I don't want to use that and I want to tell everybody that my key is compromised, then I will use my revocation certificate and I'll put it onto the key server as well. So what will happen when tomorrow you ask for a key, public key for me, the key server will tell you don't trust this key. Or don't trust this person, this is compromised. This particular identity is compromised until or unless I put another public key onto the key server. Okay, so that's something that we call it as a revocation certificate.
So if there is any such compromise happen, publish that the keys has been updated. So user who is trying to key, let's say that has revocation has already happened, and the user tries to use the same key, probably the same key. Will he be notified that even after revocation, will he be knowing that this changes has happened, or will he get a prompt saying don't trust this even after revocation?
So he will see a cross that I don't trust this key anymore.
But the revocation has happened in the server.
Correct. So I am a user. There is a server. I have downloaded a form 16. Now the key has changed on the server. I click on validate. It'll go to the server taking my key, which is there. So it'll go there and my key server will say, I don't trust this key anymore. So I will see a cross. So I have the data, but I don't have an integrity and the non-repudiation on that data.
In that way, he wants to use that file.
So he will basically refresh the key. He will delete the old key, he will import the new key, and then he will click on the validate again.
Experience, but again, where we will be doing.
See, it all happens in the background. So you don't have to do it as a user until unless you get into a situation where you have a older data and the key has changed.
What about SSH? SSH also key.
That's a new fingerprint that you generate.
Is that can we compare that? Yes.
Not really. Not really, because see, SSH fingerprint is different than your these public and private keys. What happened in a fingerprinting? You generate a very unique ID of a machine. And you said this is the ID of a machine or a unique identifier of a machine and you save it in your store. Okay, similarly, you will have my signatures in your store, I will have your signatures in my store as a system. So when I try to connect with you, for the first time, it will say this is a fingerprint of the server that you are connecting to. Do you want to save it or not? I say yes, trust this and save it. So once you are in my trusted store of the fingerprints, next time I don't get the warning. That is required when we are doing a passwordless authentication. Where I trust you, you trust me. I don't need a password to log into you. You don't need a password to log into me. So based on those authorized keys or the fingerprints, I can tell I trust this key. I don't need a password for this. For user authentication.
So when we connect to the first time, it will give us that small warning bar.
Fingerprint, yes.
We'll say yes. If it's saved in a file, the IP address matching.
Correct.
Second time when we do it, it will not ask for that particular question. However, it lasts with the password.
Correct. That's a user password.
Okay.
So if I have to set a password-less authentication to your machine, so I will have to say install this my authorized key in your server with this username. So when you connect for the first time, you have IP and the authorized key. When you do a password-less authentication, you have IP, authorized key, and the user. So now I know that if there's a connection coming from root, from Shri Krishna to me, I have to trust that user. IP matches, fingerprint matches, user matches. And that is why it is a dangerous practice.
So automated scripts, those things don't be used.
For automation, you have to use it. For automation, otherwise, your script will ask you or prompt you for the passwords every now and then.
I have a question.
Yes.
That's again related to the public interview. Just take an example of this Aadhaar card.
Correct.
So there are crores of people who have Aadhaar cards. So
Yes.
obviously each one would have their own private key. So will there be a repository of centralized repository that each of these uses public also would be there and that would be authenticated? That the process or
Just say again, sorry.
like there are crores of users who have Aadhaar cards.
Correct.
And all of these are digitally signed. So
Digitally signed by Aadhaar, not by user.
Ah.
Hmm.
So in that scenario, so suppose if I'm getting the Aadhaar card, so I would have my own private key.
No, Aadhaar or the UIDIA would have their private key.
Yeah.
You are trusting UIDAI for their authenticity. You are trusting the Aadhaar center. You're not trusting yourself. So you get a certificate or that Aadhaar document from UIDAI. When you get that document, you say verify the identity of this server from where I have downloaded the document. So it trusts the identity of a UIDAI, not of yours. So how many of you do a tax submission by yourself? Okay. How do you do it? You authenticate via bank, correct? And then you file the income tax returns. That's one way of doing it. How many of you have witnessed that if there is a tax to be filed for an organization, there is a need of a digital signatures. So there's a dongle that comes. That dongles you basically pay 1300 rupees, 2000 rupees to get a certificate on your name. So it is as good as proving an identity or signing a document. So you get that document with you or you get that dongle with you. You connect that dongle with your laptop. You open up a tax return website for a private partnership or the public entity. When you do a file return option, you get an option whether you want to use your digital signatures and upload the XML file or not. The moment you say yes, a Java app loads, which reads your key or your digital signatures from the dongle, signs the entire document and sends it to the server. At the server end, they will have your public key from the CA, who has issued you the private key. There they will verify your identity based on the key that you have inserted into your hardware, into your laptop.
So the dongle would have the private key.
Dongle will have the private key.
So this private key is then used for just again encrypting and sending across.
So in this particular case, digital signatures.
So these will be visible
Visible?
as in clear text.
No, it's not clear text. It's a key, encrypted key basically. So you can,
Encrypted or pre-encrypted, yes.
so it's a key. It's like a numbers 1, 2, 3, 4, 100, 0, X, Y, Z. So it's a long key. Like if I'll show you the key. So it's basically this much of a text.
Yeah.
You can't note it down, you can't read it, you can't store it. Only way you can take is a snapshot or copy paste. If you are able to do so, you have compromised the key. Then generate a revocation certificate and issue that.
So this, whatever is in the document, that is encrypted text.
That is encrypted text. So it is not like the Java app can take your key and send it to somewhere else. So you have to enter the password, give the permission, then it reads, encrypts the document and sends it or uploads it. Now, on a GPG side, you can create a key you can create your public private key by GPG full generate key switch. So that will generate the keys for you. Similarly, you can generate the revocation certificate by genrevoke command.
The continuation of that.
No. So let's say I have GPG installed. So GPG and I will say full generate key. So invalid option, so I'll just go with generate key. GPG2. Gen key. So different options and different variants. Now you select the algorithms that you want to use. So you have four: RSA, DSA, RSA, DSN, Elgamal, DSA, and RSA. You want to use it for signatures only. You can use with DSA or RSA, either one of it. You want the encryption, which is RSA and RSA, you can go with that as well. Enter the key size that you want to generate. More the key size, better it is, but you need more computation power there then. Then what is the expiration schedule that you want to set for this? You want to expire this key in months, days, years, you can specify that. So let's say if I say 0, the key will never expire. I have to do it manual expiry of the key. Yes. Then my real name, because the key will be generated on my name. Email address. So this is the user ID that I will have. Paras Arora with the email address. Okay. Now, do I want to change anything or do I want to acknowledge this and accept it? Okay, so I'll press C to commit. Oh, okay. Comment, sorry. Uh, and then okay. Now it is asking me for my passphrase. This is what my private key would be to open up the conversation or the content. I'm setting it right now. Okay. So if you see, I have one signed, zero trusted keys right now because there is nothing. This is a key fingerprint, not the key. ID of a key. Okay. And this is what my key reference is. Okay. Now, if I say list keys, this is the key that I have in my store. Okay. So that's a public key that is there in my store. Similarly, I want to list down my secret keys. This is what I have used is a list keys. I can list down my secret keys as well. Again, it will be the ID of the key which will be printed, not the key. So this is what my, if you see, this is a pubring.gpg. That's a file. This is a secring.gpg. That's a file.
So both are plain text files.
Both are files.
Plain text.
Huh. But if you, for example, if I cat this, or before I catting, let's say I want to see the type of a file. It's a data file. It's same like the slice that we created earlier. Okay. Now, if I cat it, you will not be able to, sorry, send anything into it. Okay. So this is what my key. I want to delete my key. So like I have used list keys, I can use a delete keys as well. Okay. So this is what my ID of a key looks like. So let's say this, then I will say GPG2 delete key. Unknown system error. Not found. Right. Wait. Yeah. So I have to give the ID with which of which user I want to delete it. So it's just giving me a warning, use option delete secret keys first to delete the secret key first and then the public key. Delete the secret key. Yes. And then I'll delete my public key. Now if I list down my keys, nothing.
So here custody is like CA.
Local CA.
So we can kind of maintain our local certificates and in our internet we can manage all this.
Yes. Okay. Now let's generate the key again. I've got the key. Okay. Now, what I have to do is I have to generate a revocation certificate, let's say, so that tomorrow, if something goes wrong, I can play around with that certificate or import that certificate to nullify my key. Okay. So PPG2. So GPG2, where I want to save that certificate or the CRT file, that path, gen revoke for generating a revocation certificate, and then the user ID for which I want to generate it. No reason. Okay, now if I see, I have this revocation. I have just generated so that tomorrow, if my key is compromised, I can use this certificate to make that invalidated.
So, when you create a key, there's an expiry date.
Which is 0.
Yeah, so when you mention an expiry date and when it gets expired, does it go to the revocation list?
No. You just have to generate the key. Okay, so right now I have just created the certificate. That's it. Now this certificate, if you see, it is RWRR. I don't want this certificate to be read by everybody, just to secure it. So what I'll do, chmod 600.
Specific to the user or
Specific to the user, not the root user. I have
your ID?
given the ID. I want to generate a revocation certificate for this user ID.
Where are the original files stored?
Which file?
GPG. Secret file.
That is under my root /.gnupg slash. So it's a hidden directory basically. So if you do, this is the file path. Clear? Now, you want to practice? I'll share it before I go to it. I'll share it with Rahul. Rahul can put it on the LMS, so you will have access. Yes. No, it is not there.
Only the recorded videos are there, but
Yesterday we will show.
no, he has not uploaded.
This.
People is on.
Yeah. It's already uploaded.
Probably from the previous session they must have uploaded. Last session से किया है वो देख चोर.
So I have another question. So essentially, these public and private key concept. So We see it's applicable to users.
Hmm.
Will it also be applicable to servers?
Yes. Any identity.
Any other?
So for example, if you look at the IoT devices today, right, how do they know that this is the person that or this is the device that I need to connect with and not the another device? So when you search the device, you add the device, you're basically adding the fingerprint of those devices, not the public private key, but you are adding those fingerprints of the devices to your Alexa, let's say. So Alexa would know, okay, these are the fingerprints that I have. From the Bluetooth perspective, these are the 10 devices that I am connected with, not the 11th one. This is a normal, simple IoT device. In an industrial automation, you will have the public and private key even for the IoT devices. जोएल को नींद आ रही है. सब कुछ पता है. Or probably we'll take a 5-minute break. Yeah. So we'll hang on to this slide. You can practice it out. We may extend a day more because there's still a lot of stuff to be covered. So we are not rushing into it. Okay, so if needed, we'll probably next week and then next week.
So ideally, it is supposed to be next.
Yes.
Windows will be having the counterparts.
Correct. That's why I just need another day for it. Because Linux is still left. Next session will also go on Linux. So yeah. Windows is easy because it's navigating next. So that is easier. Since you have got the concept here, learning Windows is much more easier. Because less of a command line, more of a GUI. Right click, properties, text, this, there. Since you have the context, you understand why that checkbox is there.
So we'll be like active directory and all those things will also be there.
But I think that is a different model, active
We
directory.
learn active directory.
Yes.
These two classes.
So all of those objects also will have a active.
That is where one more day.
I thought it's a different module on active directory.
Oh, race people just sucks the blood.
is okay. Better than that.
I think I'll understand more of Windows probably.
எப்படி நீங்க சொல்ல access பண்ணீங்க?
So all the comments.
What is stuck on one screen?
Come here.
Joel, what we need to plan now? Even before the exam. Trust the evidence out there.
No, he is not opening his mouth during the exams.
No, it is not.
Don't
Do it in the screen record.
Yeah, good though. I am doing all the content business. Looking at the camera only.
I didn't know that there was strategy. I did start the pro. Then I on my this is out.
There is some. Similar in what encryption ಮಾಡಿದೀನಿ. ಓಕೆ ನಾನು ಪ್ಯಾರಾಗ್ರಾಫ್ ಏನು ತೋರಿಸೋದು ಅದನ್ನ ನಾನು ಬೇರೆ ಟೂಲ್ ಅಲ್ಲಿ ಮಾಡಿದೀನಿ. ಯಾಕೆಂದ್ರೆ ನಮ್ದು ಪ್ರೊಫೈಲ್ ಡೇಟಾ ಎನ್ಕ್ರಿಪ್ಷನ್ ಅಂತ ಸೊ ಬೇರೆ ಸಾಫ್ಟ್ವೇರ್ ಇಂದ ಡೈರೆಕ್ಟ್ ಫೈಲ್ ಎನ್ಕ್ರಿಪ್ಟ್ ಮಾಡ್ತೀನಿ. ಇದ್ರಲ್ಲಿ ಅವರು ತೋರಿಸಿದ್ರು ಮೌಂಟ್ ಎನ್ಕ್ರಿಪ್ಟ್ ಆಯ್ತು ಬಟ್ ಇನ್ಸೈಡ್ ಡೇಟಾ ಎನ್ಕ್ರಿಪ್ಟ್ ಆಗಿಲ್ಲ. ಬಟ್
Encrypt the amount.
yeah, it's just they are just encrypting the amount. But the profile what I am working will encrypt the files itself which resides inside the file system. So even if you read those files, okay, it will be in cipher language. And that too we do it on a database files. Okay, so this is somewhat similar related. And our forensic team is that like SOC team is there. They use all this fun stuff to do that investigation. But with them I have not worked much, but I have heard like they use some open source tools or not to do the forensic.
That is FPK, source and
Yeah. Once like there was one of our customer got compromised. Okay, so they are into diesel distribution within the US. Okay, so they had some remote employees in Pennsylvania. Okay, now there is one place called Buffalo. It's in New York. There is a place called Buffalo and they have their refueling station there. So they fired few employees. They have taken the laptop and they have run. So with that they had compromised. Then they were like, when they started searching the user, they told who is this user? They were like, this person was terminated 1 month back. Then where is his laptop? They are not collected. He has went and given to some person. They have hacked it.
there's base itself is messed up.
Yeah. Like, even these days they have that case in the blog and all. These are direct ransom attack. I got a sub ticket from my previous organization. Okay, what I did, I just shared some business requirement document which is having some minimal amount of coding in the document. So what happened, I sent over an email and that got over the SOCP. They got and they sent an email. That was happened 2 months back. Okay. And before the end of my day, my last working day, again I received an email saying that this request is successful. I mean, you did this, what is the purpose of it? I told him actually the ticket got closed already.
Actually, I have a doubt. One of my colleagues was working around at the company. We have this service principal for authentication. Service principal. He's got a GitHub code. He's built an infrastructure. And he's forgotten whatever code that he had done for the company, he took it in his own repository. Everything was good on 10, 15 days. And all of a sudden, he uploaded that code to his public repository, his own GitHub repository. And then all of a sudden, these guys from
We thought you were to collect your offer letter. Hey man, he's busy now, he's not giving offer letters. But he gave you a biscuit. Yeah. Yes.
But your legit kept this biscuits like this, sir.
Where? Where, really, it's there.
Yeah.
Ah, packets are there, man. Leave on board of
And then,
So that I don't know how they identified. They were like, it has come from this guy's repository.
People are very senior.
So for them,
Yeah.
still only
But they are more gelled actually, I can see that.
Ah.
No, the service voting was like.
I think it's your identity on the cloud.
It's not my service principal is common. If you have the service principal, you will.
It's a little bit, so even we are kind of getting to know each other.
Yeah, it's the beginning, right, yeah, especially.
What?
Maybe I should go over
But
that.
see, they are very generally what.
Who?
It's already there, then I installed.
They are not children.
They are very general.
How does it matter? Bro?
We have to just get.
What I mean says, whether they're having more experiences to the interest. They were talking about other stuff. Yeah, they're having people so
They're making fun of it.
fun actually. Surprised by it. Surprised by it.
Yeah.
No, you have downloaded.
I think that service started.
No, it's a concern.
One organization, one department.
The service principal will give access to the entire Azure account.
Of that department, and now that subscription.
One thing I have noticed, the recording might have some disconnect from here because of internet issue.
That is there every day. Every day, one, not 2 seconds. Just
So we are installed, we have.
The entire Veracruz session would have gone.
Yeah.
Because they were not going.
That's not it.
Yeah.
Right, 5 minutes practice.
Do we need to get into Sudo?
Just see where the GPG is. So use the which command or where? With GPG or where GPG? It's a bin, so you can use it normally.
So for Veracruz, those are the 4 commands. We create Veracruz.
Create, list, mount, and then dismount.
So even the active directory also will cover in this model.
We'll touch it from a security standpoint, not from an administration standpoint.
Forest. But if you are covering from administration side, we have to go with forest.
Forest, tree, all that stuff. Yeah.
So Active Directory is a concept of Windows, is it, or it's generic networking?
Windows. Active Directory is Windows. User directory is generic, like LDAP.
And how about this Samba here?
Samba is covered.
Because in my previous organization, they entirely rely on open source technologies. So if you have to procure a Microsoft AD, you need to pay the license.
Correct.
So they set up Samba AD. It's only the support charges that they have to.
Correct.
It's all open source, so whatever changes you need, you can implement that.
Sir, can you switch to the next slide for to create the public key,
To create the public key.
to generate the public key?
So that will be from a full generate key or gen key. Hyphen gen hyphen key. Can see this fine. So dot and so even want to additionally generate. If I import this certificate, then it will
We never prepare license. It should be known of us.
Correction, you put that as a correction, mess up. If it is honor, you like a put that. No, no, it's must be sorry.
Send anything to them? No.
Then you had to check on Stack the Yeah, I think that's Both are same.
Just to capture the.
How could the public get the private key?
So now you
We would have created a cemetery. What option did you choose? I didn't have. Like 1, 2, 3 is big option. No. Size is just change. It has to be for the area.
Yeah, yeah, generate like it has created a public.
That's not the key.
It was created a symmetric. Yeah, the first one. Okay, it will generate.
So like a serial number, 1, 2, 3, 4. So if that's consider it as a serial, but it's not the key.
Not like, so to create a key slash.
Probably get a private key there.
That is full chain.
No, it's same thing. It's just that on some older implementation, then key works. Two work.
And symmetric. It's getting the same. Like you see the outlines like
Very
both were the same.
in the pen, not the key.
That side, go to what you're writing. We just have you guys.
This much is.
You know, entering line, close 040. Put 09640. That is going to it will become.
Registered the video.
Oh, okay.
I didn't talk.
So if you start it after like if you say 1 minute or so, I'm sitting like Pushpa. Okay, now let's say I have a key. Okay, I want to create a backup of my key so that tomorrow, if my key store is compromised, I can have a backup and I can use that to basically benefit me. I mean, I can recover it, right? So I can use export secret keys with the armor option. The armor is nothing but it enables us to export the ASCII text. So I can see what the key looks like.
Export the
Keys.
some text.
ASCII. ASCII values. So GPG export secret keys will export my private key, armor in a plain text, to which username, the email address basically of the secret key that I want to export, and the file to which I want to export it. Okay. So I can export my secret key in this file. And when I do a cat, I will be able to see my secret key. Okay.
So when you say user at the host, it's the email address.
It's the email address. So, for example, GPG2, this is what for me, GPG2 was working. Okay. So, export secret keys, I'm exporting my private key. Armor so that I can get the clear text view of my secret key. Then my email address, which corresponding user that I want to export for. And let's say let's say I want to export it here only. Where it went. Sorry. So yeah, it's just dumping on the screen. So this is the secret key. I can just copy it and paste it in my notepad. That's what my secret key is. Yeah, that's what I was saying to somebody, like, you'll not be able to memorize this. Even if you see it in a plain text, you'll not be able to see it. Right? So I can export it to by giving an output, let's say. This is what my secret key is, which is a ASCII text file. It's a clear text file. Now, if this gets compromised, then I will be in a problem. Then my non-repudiation and all that stuff is gone. Okay, so I can take the backup of my secret keys as well. Like I have done the export secret keys, I can simply say export keys that will take the public key as a backup as well. So here I have used export secret key. I can just say export keys.
Export key for public. Right.
Yes. Clear? Now, let's say I want to import a key. I've got a public key from Joel. I want to import that so that I can start trusting Joel. Right? So what I'll do, I'll say gpg -- import and the key file name. So I can export the public key. I can transmit that public key to Sudhakar. Sudhakar will import it into his trust store. And then I can communicate with Sudhakar. Simple. Correct? Simple. Hai? Guys, can you hear me? Am I on mute? You can hear me, right? Now we have created the revocation certificate. Revocation certificate, right? It is still active. Let's say I import this revocation certificate. So let's see what happens there. So nothing has happened. Yeah. Yeah. So you see this tag of revoked on that particular date. Okay. Which means I have marked this key as invalid. The key still exists. It's just that this is not a valid key anymore. Simple.
Whatever exchange that has to take place, it will still go through.
It will still go through. It's just that I don't trust you. You don't trust me anymore.
So this costs nothing. This costs nothing.
Cost as in?
You have to pay for anyone.
No, nothing.
There are certain certificates you provide.
So if you are using a key server, so for example, if I have taken up a key, like a dongle key, I have applied for it, I have got it, let's say from TCS or from other CA, I have got that key. Now I revoke that key, so I would approach them for issuing a new key. At that time, they will charge me. But the fee is not that great. It's like 1300 to 1500 is what it takes for a year. So roughly about 100 rupees per month.
And when we set a timeline, like it's valid for 6 months or 1 year. So after 1 year, after a period of 1 year, or let's say just before 1 year, do we have an option to renew the key, or will it be again be a new key that would be generated?
It'll be new key that will be it.
There's no option of renewing it.
Can we have our own local certificate authenticating?
You can have your CA server established and you can start distributing the keys and the certificates.
Do we have too many configuration on the client machines to see this?
So your on the client configuration, let's say on IE or Edge or Chrome or whatever browser that the system uses, you may have to add the CA path, basically your URL into a trust store. Similarly, in your machine, you will have to insert that as well into your trust store.
Machine, I think the Windows machine.
Windows machine, yes. So for example, if the communication is not on HTTP, HTTPS,
Is it like a self-signed certificate?
it will be self-signed only because it's a local CA server. But if you have got a CA registered and then you start doing it, then it's not a self-signed. But until the time you are having a local CA server, it's a self-signed one.
CA server is that IP itself can be something like.
That is why self-signed certificates are dangerous, no?
Self-signed application.
That is where if you do a vulnerability assessment, let's say, and you run Nessus, Nessus gives you the server is having a self-signed certificate. Why it is a vulnerability? Because nobody knows who is the CA. It is like I have signed myself and I am proving that I am myself. Right? So you trust me that I am the Active Directory. I'm not, but you trust me that I am the Active Directory. That is why self-signed certificates are dangerous. Clear? Simple. Now, whatever we are doing here in terms of exporting, importing, if we have a key server, we can do that with the key server as well. Okay. The commands slightly change in terms of a key server where you will have a send key and you will have a key server as one of the options. So rather than maintaining the key on my local trust DB, I want to publish it publicly. So I'll send the key to the server. This is the key, just keep a copy of it.
But for that, we need to have server details.
Yes, so there's one server which is pgp.mit.edu. But this is a very fluctuating server. Sometimes it is up, sometimes it is down. It is just for the educational purpose. But yeah, in reality, you will have the key servers dedicated, so you can send your keys there. Like for example, in your organization, you may have a dedicated key server in your organization. So at that time, you can send the keys to that server.
And because I have seen there's a different key management team existing. Now, how they are going to manage the servers? Let's say if I'm creating some keys and I'm hosting on the servers, everyone is authorized to use that server, or is
It depends. If they have made it open, everybody can push the keys. If they have put in the authentication, then obviously you need to use the username and the password.
and that keys can only be accessible by us. Even those who manage.
Administrators would be able to use it because you are putting the public key there, not your private keys.
So private keys never goes to that server.
Private key remains on your system.
What would be the main goal of the team who manages these keys?
Revocation, monitoring if the key is compromised or not, renewal of the keys. You have submitted a new request for a generation of a certificate, so acting onto it, taking approvals. I mean, It should not that everybody start to send in the request. I need a key. I need a key. I need a key. No, not everybody needs a key, right? So they just monitor it. So it's a complete life cycle of a key that they monitor. So generation, revocation, backup, then deletion, renewal, everything they manage.
Deletion will also happen. In deletion as in completely deleting or
Sometimes they completely delete, sometimes they don't. For example, I generated a key for Shri Krishna. Rather than writing Shri Krishna, I write Sri Krishna. I would not want to retain that key because it's not a valid name. So I will delete that key.
any of those keys has to be deleted, we'll have to go through any approval.
Change management.
This is what CA people will be doing.
Yes.
And this is a PK infrastructure.
Yes. With the server.
The server end.
With the server involved, it creates that complete PKI infrastructure.
The CA server.
Correct.
Just asking what of skill set is expected from the person who the key for technical skill.
See, technically, I don't think it's too technical, honestly, because specifically, if you look at the CA servers on Windows, it's GUI. You have list, right click, delete, revoke, renew, all that stuff you can do, expire, extend, all that stuff you can do. So technically, uh, knowledge about encryption, knowledge about algorithms, uh, process-wise, person should be strong and should have a good background check and a history. That should be it. Because you have the entire key store with you. You can create public keys and duplicate those keys and do a lot of stuff.
For on private key, how many public keys we can?
One is to one mapping.
But we can give the public key to many people, right?
Everybody. Simple. Right? I told you at the start, the subject is very simple.
Encryption. It sounds simple, but
It is indeed simple. I mean, till the time you get the concept, it is simple. If you don't get the concept, then it is tricky. Do you know how the earlier days when people used to get onto the horses, how do they do the encryption? They will just use the paper to fold and write the message and give it to you. You know this now? You don't know this.
I've seen Beautiful Mind movie somewhere.
Just give me a paper.
They fold it right and then open it and then fold it right and then open.
So the person should know how it works. He can read it.
For example, this is a piece of paper, and this is exactly the diameter that I'm looking for, let's say. And what I'll do, rather than folding like this straight, I'll fold it in a diagonal way.
I think the first person to use encryption was Caesar.
Yes, that's why the Caesar algorithm came. So it is little thick, I would say. But yeah, let's say if I draw a line here, this is a line. I mean, it's a small paper and the thickness is more. But if I use a very thin stick, there will be more intersections like this. So now I open up this and I'll hand it over to somebody who will understand this. Somebody who has the same thickness, somebody who knows from where to start would be able to wrap it up again and would be able to see something like this. Right? So that's how the encryption started. Right? I don't know what they used to do with love letters and stuff, but yeah.
But later it was unturned. They found out that.
Yeah, later it could be Panasaroda as well. So that's how it all started. But the concept is basically how you can juggle up, how you can make it more complex for others to know what you want to communicate. That's the concept. Now, multiple algorithms, endless algorithms are there. We don't have to study everything, but yeah, the concept is something that we need to be very, very clear about. Okay. Now, this is how it really happens in the real way, where you have a public key of a recipient, you have a public key of a sender, all that stuff you have. This is how you will encrypt and decrypt. So you have a sender and you have a receiver as well. So this guy is a sender. Okay. So what this person is doing is using the armor, basically the clear text certificate of the file, recipient to whom he has to send the file. So use this as a recipient, encrypt, and then the file name. So there will be an encrypted file which will be generated. You send that file to the recipient. The recipient will use decrypt and then the whatever the file that has come. And then it'll, because there's a public key which is used here, this person will be able to decrypt it.
What's the job of the private?
To open up.
What you're saying, using his public key?
So this is a sender, this is a recipient. So sender is encrypting using the public key of the receiver. So receiver will open with the private key of him or her. Clear? This is what we understood on the board. Simple.
So is this the only way to send the key to the recipient? Like
Not the key, you're sending the file.
The file, is that the
Yeah.
only way? I mean, does it, so since let's say that's the email ID, so will the file go to his email?
No. So email ID is because of the key that you are going to use. So for example, for me, I have used aurora_paras@hotmail.com. So that's a ID that I have.
It's just an ID.
Just an ID. Okay. Once that output is generated, I will send that output to somebody through email, text, whatever. Okay. I can integrate GPG with my Outlook, with my Thunderbird, all that client email systems as well. And this can happen transparently. Clear? Simple? Yeah.
Even here, this trust and this trust relation is between sender and recipient.
Hmm.
What we saw earlier was what happens on the CS server. The GPG,
Correct.
gen key and all those.
No. So this is my local server, local system. Okay. This is what my local system is. Can be my local system. What you see in this particular block is what you are sending to the server.
CS.
CS server. You may have a CS server, you may not have a CS server.
Some central authority.
Some central authority. Okay. So let's say I have a user 1 and user 2. User 1, user 2. You will take your output of the public key. You will send that public key to me. If I have a server, I will download your public key from the server. Since I don't have a server, you will send it to me via email, WhatsApp, text, whatever way. So I will import your public key in my key store. I have to send a file to you. I have your public key in my store. During the encryption process, I will say gpg-armor-r Shri Krishna.koshal@whatever.com --encrypt and the file. So your public key, which is in my key store, will be used to encrypt the file. And I will send that file to you again through WhatsApp, email, whatever way. And then you will use decrypt command to open up that file. If he gets a copy of that file, he will not be able to access that. Why? Because your key is not into his key store.
So is this what is used by the browser at the backend?
Yes.
Or is there any other GPG parallel?
GPG is just one software which is implementing the public and a private key. Concept is this. GPG is just an implementation of a concept in Linux. Clear? जोएल ने आज अच्छे से चावल खाया. Clear? Then we have a disk encryption, which we will start in the next session. Okay, I have my marriage anniversary today, so I have to attend that. Otherwise, I will be roaming decrypted entire day. Apart from the disk encryption in the next session. Okay, and Rahul will just extend one more day for the session. So next Saturday and then next Saturday as well. All right, guys. See you in the next session then. Take care. Bye-bye.
Thank you, sir.
Thank you,
Bye.
sir. Thank you.
Thank you.
Happy anniversary.
Bye-bye.
Happy anniversary.
Thank you. Thank you.
Yet on the
Thank you.
on time, sir.
All right. Take care. Bye.
Thank you.
Bye,
Sir.
sir.
Thank you.